So this is going on page 125 when we are done. We have talked about sequences. Today we are going to talk about series. Sequences and series go hand in hand. Series is more of what you will look at if you're taking BC next year, or it shows up in Cal 2. For those of you that are not taking the calculus track and anything, they can show up in other math classes as well. But all right, so sequences was like our list of numbers, right? A series is just the sum of terms in a sequence. So the sum means we do what? Add. So the sequence is them all listed out. The series is them added up. Okay? Those are the difference between the two. So if I have a sequence that looks like this set of numbers, 2, 4, 6, 8, like so, that's the sequence. The series would be the sum of that, which would be 20. If I have 2, 4, 6, 8, ... meaning that it goes on and on. When I add all those up, what do you think I'm going to get? Infinity, yes, because we're going to go to infinity, right? If I have 1 over 2, 1 over 4, 1 over 6, 1 over 8, and that keeps going. When you add all those up, you get 1. We'll look at y a little bit later, but that's what you get. So this, just a series in general, is the sum of all of the terms, but we could have partial sums. So if you look at, just look at number 1 here, and then I'll give you the definition. But you've got 2, 4, 6, 8, 10. So this sequence goes on infinitely, right? There'll be an infinite number of terms in that sequence. But I only want to find S sub 7, which means, in this particular case, the sum of the first 7 terms. Okay? So if you want a partial sum, it's a capital S and the little subscript of how many terms we're adding up. That's what the notation is. And so a partial sum is the sum of a specified number of terms in a sequence. So if I want the partial sum for each of these sequences, so S sub 7 is equal to, I would add 2 plus 6 plus 10 plus 14 plus 18. Okay, that's 1, 2, 3, 4. That's 5, so I need 2 more. What would the next one be? 22, and then what? 26, right? So that's the first 7 terms. When I add all that up, I will just tell you that that is equal to 98. Okay, y'all can add, so I'm not so much worried about that. Okay. Is this an arithmetic or a geometric sequence? Arithmetic, good, because we're going up by 4 each time. Alrighty, so then let's look at number 2. I want S sub 5. And this time I've been given a rule. So the sum of those first 5 terms would be 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. Right? And again, I will just give you what it is because I'm quite sure you can push the buttons. We'll just save some time. You would get 225. I'm sorry, I didn't hear you knock. We all good? Now, that can get a bit tedious, right? If I want the sum of the first 100 terms, I don't want to have to list them all out. So we have some notation, we have some rules. We're going to still keep listing them out, but I'm going to show you the notation first, and then we'll get to the rules. But a way to represent series, okay, a way to represent a series using the Greek letter, anybody know what this Greek letter is? Sigma, very good. Sigma to denote the sum. So it can be called summation notation. It can also be called sigma notation. So you have this big weird looking E, that's a capital sigma, Greek letter. And so on this one it says, goes from n equals 1 to 5. This n matches whatever variable this is. So if this is a k, this is a k. If this is an x, this is an x. If they match, that means this is the, so this n equals 1, this is going to be the first term number. And then this is going to be the last term number. Then this thing here is the formula for the sequence, whatever the sequence might be. So what that notation means here, if I want to actually find that sum, I substitute that 1 in, so I will have 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5, right? So I've gone from 1 to 5, and when I add all that up, that gives me 30. Any questions on that? All right, so we don't always have to start with 1. Our first term number in number 3 is actually 2. So we expand this, I'm going from 2 to 6. So when I do this, that's going to give me 2 squared minus 2 plus 3 squared minus 3 plus 4 squared minus 4 plus 5 squared minus 5 plus 6 squared minus 6. You understand where all that came from? Are you capable of typing that in the calculator? Yes, so then I will just give it to you. You would get 70. More worried about the process here than the actual answer. So you get the idea here. If you have a number on the outside like we do here, we have the negative 9/4 times that sum, then you're going to have negative 9/4 times, and then you do the sum. Here we're going from 1 to 5, so this is 2 times 1 squared plus 7 plus 2 times 2 squared plus 7 plus 2 times 3 squared plus 7 plus 2 times 4 squared plus 7 plus 2 times 5 squared plus 7 plus 2 times 6 squared plus 7. Nope, why do I do that? I needed to stop at 5. I don't know, I just kept going. I wanted to see if you were paying attention. Good job. All right, so I stopped there, right? Because I was thinking about my next question here. Tell me something before I'll just tell you what it is, you don't have to type it in, but tell me something you know is going to be true about this answer. What's it going to be for sure? Negative, right? Because all this stuff in here is positive, right? And then that's multiplying by a negative number, so clearly it's going to be negative, but it's a weird fraction. It is negative 1305 over 4. Like I said earlier, that's very tedious, right? So it would be nice if it was arithmetic or geometric if we actually had a formula and we didn't have to list them out, because that's not even that many terms, but that gets a little bit much, right? We all good with that? Okay. So the next part is where we're going to talk about some actual formulas, and 126. I knew I would forget. This is going on page 126 when we're done. So now we're going to talk about arithmetic series specifically. So an arithmetic series is just very simply the sum of an arithmetic sequence. So when you want the sum, okay, there is a formula that we can use that looks like this. S sub n, right? So it's going to be our partial sum there. That's equal to n times a sub 1 plus a sub n over 2. So n, of course, is the number of terms. A sub 1 is the first term. Doesn't necessarily mean it's actually a sub 1. It's the first term that you're going to use, right? And a sub n is the last term. Everybody good with that? Okay, so we want to find the indicated sum. So we want to find the sum of the first 18 terms. Okay, so in this case, I am starting, like if it's written this way, it is definitely the sum of the first 18. We are starting with the first term. So I need a few things. I need n. N here is what? 18. Right there. The first term is 7. And then I need the 18th term. Well, I don't want to have to, I mean, I could figure it all out and keep doing whatever, but at the same time, we have a rule that we did that says a sub n for an arithmetic sequence is d times n minus 1 plus a sub 1, right? So what is the common difference here? 3. So this is 3 times 18 minus 1 plus 7. So go ahead and find the 18th term. And then Edward, tell me what the 18th term is. 58. Y'all agree with that? Yes. Good job. Thank you. All right. So now I want to find the actual sum of the first 18 terms. That is equal to n, which is 18, times the first term, which is 7, plus the last term, which is 58, all over 2. So you go ahead and type that in and find the sum of the first 18 terms. Synthetica, tell me what you get. 585. Y'all agree with that? Yes, thank you very much. There you go. Okay. What questions you got? Anything? All right. So then let's look at let's look at number 2 here. What is n? 35, right? So first term is 50, and then I need the 35th term, so y'all go ahead and figure out the 35th term there. I'm sorry, what? What do you mean? What do you mean input it in the calculator? I mean, I don't understand the question. All right, well, I gave you the formula that's up there in green. That's from Tuesday. It's from the video from Tuesday. All right. 35th term. Max, what do you think? Negative 222. Y'all agree with that? Yes. Okay, good. So if you haven't already, go ahead and find the sum of those terms. So I want the sum of the first 35 terms. Ruby, what did you get? Okay. Wait. I don't think that's right. Let me see what you typed in. Okay, where'd that second 35 come from? That should be the 35th term, which is negative 222. Yes, very good. Negative 3010. Y'all agree with that? Yes. All right, thank you. Okie dokie. So that's if we've got them listed out. Now, if we have this summation notation, we're going to skip number 3. We're going to go to number 4. I have here, we're going from j equals 4 to 17, right? So I need to figure out how many terms that is, and it's not 17, right? Because I'm not starting with the first term. So what do we think n equals? What do you think? 13? Does 13 sound good? Sounds good, right? Now count it on your fingers. I got 13 and I got 12. I'll tell you neither one of those are right. But I understand where you're getting 13 from for sure. How many you get? So go. I start with term 4. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's 14, right? You can't just take 17 minus 4, because think about this. If we did that here, we want the sum of the first 18 terms. We're going from 1 to 18. If I just do 18 minus 1, that gives me 17. It's not 17 terms. Does that make sense to you? Okay, so the way that, I think the easiest way to really think about this is to say that I have that n is equal to last term number minus first term number, and then plus 1. Okay, add 1 to it. So go ahead and subtract like you were thinking, but then you have to add 1. So don't forget to add 1, or when your n's wrong, then nothing else is going to be right. Okay, we good with that? So that means that if I'm going to do 17 minus 4, that's 13, and then I add 1, so my n is actually 14. We agree with that? Okay, so then I need the first term. Now, first term isn't a sub 1. The first term I have, since I'm starting with 4, is actually the 4th term. Okay? This is going to give me 5 times 4 minus 27. So that's 20 minus 27, which is negative 7. And then I also need the 17th term. It's going to be 5 times 17 minus 27. And I'll let one of you tell me what that is. Edward again. It's your lucky day. 58. Is that kind of weird? That's what you had last time, too. Called on you twice, same number both times. It's almost like the spirits know. Okay, so I have all of that. Now that we have all that from there, then we can put this all together. So the sum of those 14 terms is going to be n, which is 14, times negative 7 plus 58 over 2. You figure out what that is, and I'll let one of you tell me. Nicole, do you have your answer yet? 357. Y'all agree with that? Yes, thank you very much. All right. So number 5. What is n? 36. Very good. All right, so then you go ahead and find the third term, because that's what we're starting with, and find the 38th term. Give you a second to find those two. All right. Frida, did you get the third term? What'd you get? Yep, negative 25 over 2. Then go ahead and give me, did you get the other one? Okay. Negative 65. Okay, y'all agree with those two? Yes. Now, I didn't write any work down because I didn't want you just copying mine down, but again, you should have like something written down and not just a number. Remember that. All right. So now that you have that, go ahead and find the sum of those first 36, or not, I'm sorry, not the first 36 terms, the sum of those 36 terms. Bless you. All right. And Elizabeth, do you have an answer yet? Negative what? I'm sorry. 945. Do y'all agree with that one? No. Is this what you have written down? Yeah? Let me see what you put in your calculator. You didn't clear it out yet, did you? Oh, you missed the negative on that one. There you go. Okay. Negative 1395. Just missing one little simple sign can just mess up everything, right? So negative 1395. Okay. Any questions? We all good? All right, let's look at a couple of application problems. All right, so Michaela is training for a marathon. She ran 2.4 miles the first day, 2.55 miles the second day, 2.7 miles on the third day. If this pattern continues, find the total distance she ran after 60 days. Okay, so what is our N here? 60, right? For 60 days. Your first term is how far she ran that first day, which is 2.4, right? Then I need the 60th day, which I definitely don't want to list them all out. So when I find the 60th term, that's going to be, what's the common difference? 0.15. Okay, good. So 0.15 times n, which is 60, minus 1, plus 2.4. So find that 60th term. And then Emily, once you have your answer, let me know. Okay, go ahead and give it to me as a decimal. 11.25. Okay, so using the fraction would have been fine, but kind of the general rule, just so that you understand, you can be more comfortable with it. We have decimals in the question, so using decimal here is totally fine. Okay, but either one would get you the right answer in the end. It really doesn't matter. Okay, so then I want the sum of those 60 days. So go ahead and find that using all of that info. And this woman's crazy, right? Is it just me running that much? I don't know. I question people like that. Comes from a place of jealousy, really, not judgment. Yeah. Yeah, me too, kind of. All right. Vincent, what you got? Okay, 409.5, I'll agree with that? Yes, 409.5. Now, being an application problem, we should write our answer out in a sentence. That's something that you need to get used to. And the easiest way to do that is just to kind of reword the question. It says, if this pattern continues, find the total distance she ran after 60 days. So I can just say the total distance, it's okay to abbreviate, she ran after 60 days is 409.5 miles. Okay. Any questions? When you're writing out your answer, abbreviations are fine as long as no matter who reads it, your abbreviations would make sense. If you're making up abbreviations and acronyms because you think it's shorter, that's great. But if nobody knows what you mean, it's not going to work. Okay, we good? Okay, so let's look at number 7. Tickets for a concert opened up for sale online. The number of people that purchased tickets in each of the first 4 minutes is shown at the table to the left. If this pattern continues and the concert venue can hold a maximum of 75,000 people, find the number of tickets left after the first 2 hours. Okay? So in order to find the number of tickets left after the first 2 hours, what do I need to find first? How many were sold in the first 2 hours? That makes sense? Okay. So what would my n be, do you think? Is it going to be 2? No, because this is done by minutes, and it's asking about hours, so I have to use 120, right? Always pay attention to your units on stuff. So your first term, so in the first minute, 35 tickets were sold. Clearly this wasn't Taylor Swift, right? And then I need A sub 120. And this is going to be, what's the common difference here? 8, okay? And be careful, especially in a table, that, okay, the difference is 8. Make sure you know if it's a positive or negative 8. Only a positive 8 would make sense here. But, you know, just when you subtract, make sure you're paying attention to the direction of subtraction so you know the sign of your number. But, okay, so it is 8 times 120 minus 1, plus 35. Children. A bully, he just hurt himself. He hurt himself because he was doing something to you? So he deserved it? Okay. Then I'm okay with that then. All right, so that 120th term, Aaron, what'd you get? $987. Do we agree with that? Yes. Okay. So then let's find the number of tickets sold in the first 2 hours. So you go ahead and find that. Nicole, again, what did you get, hon? Good. 61,320. We all agree with that? Yes, good job. Is that my answer? No. I have to subtract because this is the number of tickets sold. I want the number of tickets left. So I have to take that 75,000 and subtract 61,320. And it gives me 13,680. We agree with that? All right, so then I have to write my sentence. Let's find the number of tickets left after the first 2 hours. So I can say after the first 2 hours, there were 13,680 tickets left. Are there different ways to word that sentence? Absolutely. But the important things are that you say what you're actually trying to say and that you have the correct units on whatever your number is. And that's that. Okay, we good? Questions? All right, your assignment is in Delta Math, but you're going to have to give me a second to click the buttons.